So let's plug in these values that we have for x here, this -2, -1, 0, 1, and 2. Let's plug them in to the function f of x equals x cubed. So if we plug them in, then it will be -2 to the third power. So what is -2 times -2 times -2? What is that going to give us? What? Negative, well, you times 2, 1 too many. -8, okay? Because 2 times 2 is 4, times 2 is 8, right? So that'll be -8. What if we did -1 to the third power? So -1 times -1 times -1, what would that be? -1. Then what about when we plug in 0? 0 to the third power is just 0. What about 1? So 1 to the third power is just 1. And when we plug in +2 to the third power will be +8, right? So let's go ahead and graph those points. Then we have the point when x equals -2, y equals -8 of x cubed, so we're going to plot that point. Then we have -1, -1. Oh, mine's not very centered. And then the point 0, 0. The point +1, +1. And what is our last point? 2, 8. So this is the parent function of the cubic function, okay? It always goes through these points when it's x cubed. So let's just kind of make a curve through the middle there. We don't want straight, oh, I didn't even go through that point. We don't want straight lines, just kind of curves right there. All right, so now when we're looking at our function, let's figure out some things here. Excuse me. Domain is our what values, x or y? X values. So domain is your x values. And what this R is here saying it's all real numbers. Because if you look at this function, will it keep going to the left and to the right? Yes, very slowly because it's really steep, but it will be, right? So if it keeps going to the left and to the right forever, then that means that our x values can be anything. So that's from -infinity to +infinity, correct? Okay, now think about our range, or our what? Y values. So on this function, does it go up forever and down forever? Yes. So then our range is going to be everything -infinity to infinity. And then if we look at the ends of the function, so this says as x approaches +infinity, or it means it goes to the right, so this is the right end behavior. So as x goes to the right, where does f of x go, or y? As x goes to the right, where's the end going? Up, right? So that means f of x approaches infinity. Okay? Now, as x goes to -infinity, that's the left end behavior, so LEB is another term for it. So as x goes to the left, where does the function go, or y? Down, right? So -infinity. Good. Now, zeros of the function, another word for that is x-intercepts. So how many times does this function cross the x-axis? Once. And that's when x equals 0, right? When x equals 0, there's the x-intercept at 0, right? So another way that you could write that is just name the actual point. So the point would be 0, 0. So either one, when you're naming the zeros of a function, you can say x equals 0, or you can just name the point. Okay, the next two things I want to teach you, and then I'm going to do the other two things later, but positive. So A function's positive when it's above the x-axis. So I'm going to just highlight so it's positive, this green part. And we always list it according to x, not y. So that's where x is what value? 0. And then where x goes to, because will this keep going to the right? Yes. So from 0 to infinity, this function is positive. Okay? So then we're going to write from 0 to infinity, this is above the x-axis. Now, where is it below the x-axis? Nope. Nope, because it shares a point where it goes positive to where it goes negative. It shares at 0, so just do parenthesis. Okay? Okay, it's negative, this section right here that I highlighted. So it's negative from there to there. But how do we say that according to x? That's for x is negative infinity to where x is 0. So negative infinity to 0 is where the function has negative values. Okay? Then we're going to do the other two, increasing and stuff, either tomorrow or not Monday, Tuesday. Okay, let's do question. I'll tell you in just a minute, yeah. Okay, write this example under what we had there. So f of x equals negative x plus 4 to the third. Mm-hmm. Okay, so let's think here. Before we graph it on the calculator, we know a cubic function has this overall shape, okay? Okay, if it's positive, like our positive x cubed that we did before, the first example, it will always be down on the left side and go up on the right side. It will always do this. So whether it's x cubed plus 5 or 2x cubed, 10x cubed, it doesn't matter. It will have this overall shape. So what happens with the negative, William? Or were you going to ask me another question? Okay.
So if it's negative one, it would be no, we would have to get that right there. It would go from the negative side down to
Yeah. Yes. So because the negative reflects it over the x-axis, right? So it's kind of like if we just flipped it, right? So instead of going in this shape, it's going to go the opposite. It's going to go like this, right? So we know the negative makes it, it flips it. What does this plus 4 inside of the cube do? Left. Good. So it'll go left 4. So we don't even need to graph it in our calculators because we just know that it will do that. Which you can always graph it if you need to, but it's just nice to know. So let's just go left 4 on the x-axis. 1, 2, 3, 4. Because x cubed always goes through the point 0, 0. So if we go left 4, then it's going to go through what point? Negative 4, 0. So we're going to have that point right there. And instead of going down and up like this, we reflected it, so it's going to be like this. Something like that. Yep. So sketch that next to this stuff somewhere. Okay? Yeah. So the negative made it flip, so it changed. Now on the left side it goes up, and the right side it goes down. Okay, so what is the domain? Will it go forever to the left or to the right? Yes. So then the domain is negative infinity to infinity. So by flipping the cubic function and shifting it over, does it change the x value?
Yeah.
No, because the domain on our first one was the same thing, right? So can we say that all cubic functions will have a domain of negative infinity to infinity? Yes, all cubic functions do. Question, Katie?
Since it's in the left side of the quadrant, wouldn't it be negative infinity to negative infinity?
Well, you're thinking,
That's how I remember that.
now, you couldn't ever say an interval negative infinity to negative infinity, because that's not a range of values. So I think what you're thinking of, Katie, is it's coming negative infinity from the x, and then you're saying, oh, it's going down, so then you think negative infinity for y. I think that's what you're thinking. But hopefully this will help you, but domain, if I were to flatten this on the x-axis, would it cover the entire x-axis? Yeah, because it goes on forever, right? So if these arrows, if I were to just flatten it on the x-axis, it would cover everything, correct? So then our domain is everything, negative infinity to infinity. And our range is our y, so if I were to flatten it along the y-axis, would it cover everything? Yes. So our range is also negative infinity to infinity. So could we also say the range on cubic functions is always going to be everything? Yeah. Okay, so all cubic functions, if it has a power of 3, domain and range will just be every real number. Okay? Now, what are the zeros, or the x-intercepts on this one? Negative 4, right? So you can write it one of two ways. You can go x equals negative 4 is a 0, or you can write it negative 4, 0. Okay? Now we're going to use that 0 to help us figure out where it's positive and negative. Because this is the positive part of the graph, where it's above the x-axis. But we have to say that according to x. So negative, okay, but think according to x. So it's positive, this whole part of the function. It will just keep going, right? Up and to the left, right? So that's where x is negative infinity, because it's coming from the left. Negative infinity to negative 4. Because you have to list it according to x, not y. So it's positive from negative infinity to negative 4. So for any x value, if we plug it into here, we'll get a positive y value. Nope. Parenthesis. Don't worry about brackets on anything except domain and range. Okay? Because 99% of the time, okay, 99% of the time they share a point with positive and negative, okay? Okay, let's do negative. Where is this negative? From here to here. But what is that according to x? If we just keep going, it keeps going down forever. And to the right, what is x? Negative 4 to where x goes to infinity. Okay? So negative 4 to infinity. Because it's according, and if you want to write that, these are always according to x values, not y. And kids always get that mixed up. Always, always. Okay? Now let's do the right end behavior and the left end behavior. Hold on, my graph looks all ugly now. Okay, so as x goes to the right, where's y going? Down, right? So the right end behavior is going to be negative infinity. And the left end, as x goes to the left, where is the function going, or y? Up. So that would be positive infinity, right? So will cubic functions, look at the end behavior of this first one. They were opposites. And behavior of this, opposite. So will cubic functions always have opposite end behaviors? Yes, because they're always going in opposite directions, okay? Martine, question? Okay, so the parabola, the U-shaped, always has the same end behaviors because it's either opening up or opening down, right? The ends are the same, okay? All right, so let's get out our paper from yesterday. I'm going to show you how to find the zeros on your calculator, okay? So let's graph number one. Does everyone have your paper? If you need a new one, there's some just right here. If you need to grab a new graph paper, okay? Oh, you did? Okay, just turn it in for me, okay, Megan? All right, let's enter the first. Now, first of all, let's hit tab. We'll clear everything that's there. Okay, what? We are going to graph something. Okay? So whatever I'm pushing up here, you guys should be following along with me, okay? So, menu 1-4 clears everything, and remember, that's up on my wall, the very top left one. Okay, now let's enter problem number 1 over here on my board, which is x cubed plus 2. So if all of you push tab, and then x, and then the power button is next to x squared. So to the power of, and you see how it has a little exponent. So then we put in 3. Now, if I keep typing, so if I just put plus 2 right now, it will just leave it in the exponent. And I don't want it in the exponent, because that would be x to the 5th. So I got an arrow out of it, so just hit the right arrow, and then plus 2. Okay? Now, before we hit enter, or maybe you have already, but this is just going to be a cubic function shifted which direction? Up 2. So instead of going through 0, 0, like the parent function does, it's just going to shift it up 2. Okay? Now, we need to find this 0 exactly what it is. We know it's between -1 and -2 about, but let's find out exactly what it is. So, shortcut for that is this red one up here on my wall, the find zeros of a graph. What do we push? Menu 6-1. Finding the 0. Now, the calculator needs to know, well, what's the lower bound of the 0 and what's the upper bound? So you just move the cursor pad to the left of the x-intercept. So just go to the left, click on it. And then now it's asking what's the upper bound. So then you have to go to the right or above that 0. And now it should be highlighting it, and it will say, hey, this is a 0, which is really nice that it tells you exactly what it is. Okay, so what is the 0 at? -1.26. So on your paper, this is what you need to add to those problems, okay? We're going to add stuff from yesterday. You're going to add domain and range. We already know it's a cubic. So what is the domain range? Always going to be on a cubic function. -infinity to infinity. Good. So then on number 1 on your paper, you're going to write the zeros. And you can write it one in 2 ways. You can write the ordered pair, or you can just write x equals -1.26. Either one. I'll accept. Okay, what we're adding is positive and negative. Okay, where's the function positive? Where's it negative? And then we're adding the right-hand behavior and left-hand behavior. I sure will.